Hi students, I am Professor Veena Joshi. I teach in the Department of Geography, Savitribai Phule, Pune University. I am a geomorphologist and I have been teaching this course, Fundamentals of Geomorphology, for the past 30-35 years, and it's a very interesting and one of the most basic subjects of this course, and I'm sure you will enjoy this. So let us take a quick recap of what we did in the last lecture. We did the glacial landforms, how the glaciers are formed, what are the different types of glaciers, how do they erode, how do they deposit, what are the different features that are formed because of erosion, what are the features which are formed because of deposition, how the glacial features formed by continental glacier is different than an alpine glacier, and finally we ended and concluded our last lecture with what is an ice age and what was the ice age. In today's talk, what we are going to study and discuss is what is a desert, what are the processes which are found in the desert, what are the erosional features which we find in the desert, what are the depositional features that we find in a desert, and finally how the landforms which are formed by the river is different than how the landforms which are formed by the wind. So this is going to be the gist of what we are going to learn in this chapter. Hi, welcome back students. So now let us start with today's this talk, that is the arid landform, or in other words the landforms and the process which we find in a desert. When we say arid land or desert, the definition is water. Areas where we receive less than 25 centimeter or 10 inches of rainfall annually is defined as arid or desert. Or areas where the rainfall is in between 225 centimeter to 50, we call it as semi-arid. So arid landforms has got its own characteristics because water is absent, not actually absent, but because water is less here, wind is the main agent of erosion. So now let us see what are the process and the landform which we find in desert. But before that, we need to have a quick look at where are the deserts located. We have got one big desert in India, we call it as Thar Desert. The largest one is Sahara, the whole of Middle East Desert, Atacama Desert, Kalahari Desert, Mojave Desert, the Great Australian Desert. So these are the main deserts of the world. Deserts are of two kinds. One is called as the cold desert and one is called as the warm desert or hot desert. Because temperature is not the criteria. The criteria is rainfall. So we have got Taklamakan or Gobi. They are also desert. Leh Ladakh, they are also desert, but they are cold desert. And if we have a good look at the distribution of desert on the globe, we find one very interesting thing, that they seem to be located along a belt. From the equator to a little beyond equator on both the hemisphere is where we have got all the hot deserts located, and some of the cold deserts are located on the Tibetan plateau. And the rainfall everywhere in this area is less than 25. And Atacama Desert, there are some areas where there has never been any rain right from day one. They are so very dry. So Earth's major desert regions are associated with, there are 4 causes. Descending air of the subtropical high at around 30 degree north and south. Sahara and Arabian, these 2 deserts fall under that category. continental interiors, means the area is so far away from moisture laden winds and from the sea. Gobi Desert, rain shadow, the desert because of rain shadow, Mojave Desert, and coastlines associated with cold currents also give rise to some of the driest deserts in the world, that is Atacama. So along the tropics, because tropic is the area where it is heated throughout the year, the calorie of heat is very high. Air is heated, a convection current up, and this convection current goes and subsides somewhere around 35 degrees to the north and south of equator. And therefore, where it is subsiding, subsidence means no rainfall. Rising means rainfall. That's why in the tropics and in equatorial area there are so much of rainfall because of that. And all the deserts fall in this area. That is what we call it as this stretch. So Sahara, Kalahari, they all fall in this rain shadow. Sometimes if a mountain is obstructing the moisture laden air, then on the opposite side rainfall will not occur. This is very straightforward, because the wind is going to be pushed up, because mountain is restricting it. As it is coming up, somewhere on the way cloud will form, all the rain will be falling on this side, and by the time the wind is crossing here, it will come down and there will be no rainfall. Gobi Desert, then means the Himalaya. Had it not been for Himalaya, India also would have been a desert. Like the picture that I have. The whole of those area, the highest rainfall area in the world is Monsinram, Cherrapunji. They are all along the flanks of Himalaya. And that is, then when the cold ocean currents come into contact with the continent, they give rise to, again, the cold air is going to stop this convection system. So when the convection is not there, the rainfall does not happen. So if we look at the world map and at the deserts, we will find that along the western coast of many of the continents, deserts are there, and Atacama, the driest desert, is one of that kind. So deserts ka basic characteristics, let us have a look at it. Deserts exhibit highly angular landscape. So, suppose we are flying on a helicopter, and if we look down and look at the desert, we will see sharp rocks, everything very sharp and angular, unlike in the forested or humid tropical areas where everything is soft and round. That is because mechanical weathering predominates. So mechanical weathering means rocks are just broken. So we have got all sharp features. They are very angular, and bedrock outcrops means many rocks are exposed. There is very little soil or vegetation to soften the landscape, and deserts also have got sand. So wherever the sand is there, they become a little softer, wherever the dunes are there. Desert is area where the rainfall is very less, but that also does not suggest that desert does not have rainfall at all. When it rains torrentially, and during that time intense erosion do take place, that we need to remember. And during that time ephemeral stream, or the streams which remain only for a very short period of time, they are the characteristics. Now a very important thing, what are the different types of deserts? The first type is called as erg, E-R-G, erg, or it is the sea of sand. The largest are in Sahara and Arabian deserts, and sand covers about 20% of the world's deserts. So in short, we can say they are the sandy deserts. Vegetation is very rare. Sand probably formed during the more humid climate. The second type is called as reg, that is R-E-G, reg. That means stony desert, deserts which have got stones or pebbles, from the very fine to the very coarse, all mixed together, so they are called as reg. And then the third one is called as hamada, that is rocky, just rock. You won't find any pebble or cobble or sand or anything. We have got all the three, and you need to understand that it is not necessary that they are located separately. Sometimes one desert can have all these three characteristics together, and a very interesting example is our Thar desert. It has got all. Desert has got, the rocks which are present in the desert many times has got red color oxidation on them. And we also find the ancient carvings, very interesting carvings on these rocks which the archaeologists use in order to formulate the history of the civilization, if at all occurred in these deserts, like how we have got the Indus Valley civilization. So how do wind do the transportation? This is so very interesting, because in the previous two talks we have seen big boulders as big as this building the glaciers can carry. We also know that in the mountainous areas or during the flood, river can carry huge rocks, but we have never seen a rock flying, a rock being transported by wind, never. Wind can carry only very fine particles, sand, silt and clay. Anything which is coarser than that, it will not. And that's why in many of the National Geographic and Animal Planet movies, we see these dust storms, and they do a lot of erosion in desert areas. So the wind action, ordinarily wind is not strong enough to dislodge mineral matter from the earth's surface. What is already become loose is what wind can carry. It by itself cannot break anything. In dry, sparsely vegetated areas, the action of wind in eroding and transporting sediment creates a distinct array of landscape studied, which we call it as aeolian geomorphology. So A-E-O-L-I-A-N, aeolian stands for wind. So landforms which are created by wind is called as aeolian geomorphology. Wind carries only very fine material, but for a very long distance, very long distance. Suppose if a dust storm happens here, it will take it to, I wouldn't be surprised, it will go across a very, China tak leke jayega wo, So though it carries fine, it carries very far distance. Large particles remain near the ground and tend to be moved by surface creep. So like how we have studied, it also has got the same saltation, jumps. The particle which are coarser, they cannot be in hanging, so they start saltating, somersaults, and little coarser it will be pushed, just like that of a river transport, but it doesn't have solution. So aeolian erosion is much less effective than fluvial. Fluvial means river erosion, and it is eroded by using these two mechanisms. One is called as deflection. Deflection means winnowing. In Marathi we call it as pakharna, winnowing. Suppose we have got here sand, silt, coarse material all fallen over here. When the wind comes, wind will pick up those fine and blow it away from there. So this winnowing action is what we call it as deflection. Then abrasion. Abrasion is same everywhere, that it is the material which is carried by the wind is going to blast against some rock and it is going to crush again and it's going to create polishing or erosion. The transportation is mostly dust storm. It can extend thousands of meters up, and the sandstorm. Sandstorm closer to the ground because sand is heavier. Wind cannot carry sand to a great height, but it can carry dust. And the deposition, aeolian deposition, dunes form and shift where winds and terrain combine to slow the winds to block the movement of dunes. So, somewhere it is going to go and deposit. So, those deposited mounds are known as dunes. So, erosion, deflation, abrasion and attrition is also there. Those sand particles, when they are being lifted and carried by wind, again they are going to friction against each other, they become finer and finer, so attrition is there. Transportation, suspension, saltation and creep, but there is no solution, and you need to remember that no big rock or boulder will ever be lifted by wind. Some of the pictures, and I encourage you to go to internet and look at hundreds of pictures which are online. Many people put up these pictures from their different studies and photographs, and you need to have a look at. I'm also putting some pictures here. You can have a look at it. The coarser ones are pushed, drag on the bed. The little finer ones are up and down saltation, and very fine ones are in suspension, like how we see. Now, let us see the erosional work of the wind. So, these are the mechanism of the wind. So, now let us see what are the erosional work that it does. Deflation. So, now there is a large area or a pavement where we have got the rocks as well as fine sediments, and when a wind comes, wind will pick up those fines and it will blow it somewhere else, and it will leave behind only the coarse material. Those coarse pebbles in due course of time, when a rainfall comes, they are all close together, brought together and form what we call it as the desert pavement. It's there everywhere. When it is winnowing, when the wind is blowing the fines away from there, it creates hollows, and that hollows can be sometimes very big. They can form a lake where small stream can come and debouch into it. Those hollows are called as the deflation hollows. Pitted surface, poke mark. On the rock we have got such kind of poke marks, which we call it as pitted surface. When the wind is carrying the sand, it will blast against it, trying to remove some, and such kind of pitted surface and such kind of rocks are very common. Like in case of glacier, the rocks are very polished, very smooth, because the sand is grinding against the rock. Rocks of different shapes, we will find it in all the deserts, very smooth. But by and large, if we have a look at it, they are very sharp. Then we have got this kind of blowholes, like a bridge, and bridge as well as arch. They are also very common. They are all the actions of wind, then amphitheaters and alcoves. So, some of these features are so beautiful, and many of them are the national parks. People go to visit them, and there are many such countries in the world where tours are organized in the deserts. The next one is the mushroom rock. Rock which looks like a mushroom. That means stem is small and top is like an umbrella, just like a mushroom. And they are the most common feature in any of the deserts, especially in the Hamadas, the desert where rocks are there. How are they formed? We know that wind can lift the sand and whatever is the material only up to a certain height. It's not going to lift so high. So, whenever strong wind comes, it carries with it those sand up to about say 1 meter at the most, maybe a little higher or less than that. And every time this will come and a blast on a rock. So this blasting constantly at one height, and the wind is coming from all the sides. In due course of time, the lower portion becomes all carved, whereas the top portion, which is not touched, has remained, and this is how these mushroom rocks are formed. Such kind of features also are very common. What we see, a pillar, and on top of that a cap is there. And one more word of caution to all of you students is that what I am trying to show is all the features which are found in different deserts. You cannot or you should not assume that all the features that I am showing it to you, they have to be found in a desert. It's not like that. But different deserts, because it depends on the wind characteristics, it depends on the rock characteristics and so many things. So this Cappadocia rock, they look quite beautiful, but they are formed only in certain areas where nearly horizontal plateau areas with different layers of resistance of rock. The Cape rock plays a very, very important role. The softer layer is below, and in due course of time, and you have this kind of, which looks like a rocket, fire rocket that we play in Diwali. It looks like that. Zugen. This is a word which comes from Germany. They look like ridge and furrow, tabular blocks. So Zugen, like this. Like a table, on top there is a very resistant layer, and out of nowhere it just comes up like this. Zugen. Yardang. This is another feature which we find it in the desert. What it looks like is, it is when we have got hard and soft rock arranged on the surface parallel to each other, wind will be eroding differently. Where the soft rock is there, in due course of time that will be eroded faster. So it creates such kind of furrow and the ridge, long ridges in between the furrow. These are the satellite image, aerial photographs. So they are called as yardangs. They look actually quite very attractive. We find it in China, this kind of yardangs. Zugen. The difference between Zugen and a yardang is, in case of Zugen, the hard rock and soft rock are arranged vertically. On the top is the hard rock and below is the soft rock. So it is creating a kind of a pot with a cap. Whereas in case of yardang, we have got parallel hard, soft, and that's why we have got the hard one have remained as long ridges and the softer one has got eroded. Whenever there is any rock fallen in a desert, they will be shaped in a triangle. They are called as ventifacts, or we call them as the faceted rock. Let us take an example. Today we place a huge rock in a desert and keep it for, let us say, 1000 years, because in geomorphology we don't talk about 10 years or 20 years. Everything is in terms of 1000 years, million years. So what is going to happen is, wind is going to blast with the abrasional tool on one side today, on the other side next day. In due course of time it forms into this kind of faceted rocks which are called as ventifacts, and all deserts will have them. Now the depositional work of the wind. The dust storm or sandstorm, once they are generated, they can go for thousands of kilometers away, somewhere where the velocity of the wind checks. They start falling down and they get deposited in the form of three. One is the ripple, next is the sand dune, and the third is the loess. An angle of repose, depending on what is the size of the sand or a silt, what will be the height is dependent on that. The coarser the material is, the angle will be steeper. The finer the material is, the angle will be gentler. So now, these are the ripples. They are very common. We find them in sea beach also. So these marks, ripple marks, they look like blanket ka some design. Next is the sand dune. Sand dune is something which everybody is aware of because we see them in pictures. Depending on their shape, we give different names to it, and the one which is very common is called as Barkhan, Barchan, Barkhan dune, which is, it shapes like horn or crescent, half moon. But if we look at the 3D picture of a Barkhan, what we see is the slope is very steep and it is concave, and the slope outside is gentler, and they are found where there is abundant supply of sand and wind is kind of unidirectional, not from different direction. We have got something called transverse dune. That means direction of the wind is from north to south or south to north, and the direction of this dune is from east to west. Such kind of dunes which is defying the direction of the wind, they are called as the transverse dune, and they run for miles and kilometers. We have it in Thar desert as well. Saif, that is also very long dune, but the difference between transverse dune and saif is following the direction of the wind. So it is parallel to the direction of the wind. And once again, not all type of dunes will be found in one desert. Each desert will have one or two predominant type, because the formation of this dune itself is because of the different wind characteristics. So wind characteristic will not be same in all the deserts. So different deserts will have different types of dunes. And in Thar desert we have got such kind of dunes, but of the smaller size. In Australia you find plenty in Australia. Star dune. It shapes like a star. Like you know, let me see if I have any picture. Yes, it looks like a star. So star dune is very common, and sometimes we have got deserts where the star dune, hundreds of them are there. They are formed in such areas where the supply of sand is not that much, limited, and the wind is variable in direction. So star dune, some of the Barkhans, they are so stable, they have been stabilized, and they are so big that there are even settlement in the inside of the curve. And one important thumb rule that we need to understand when we are talking about different type of sand dune is that why different shape of dunes are formed, that are dependent on three things: supply of sand, the direction of the wind, and the vegetation characteristics. Sometimes vegetation plays a very important role because it stops the rolling sand from proceeding ahead. And One such example is the parabolic dune. So parabolic dune is a dune which is like a hairpin. What we saw that even Barkhan is also curved, but they are exactly opposite in the sense that in case of Barkhan, it is the curve or the horn is to the downstream or towards the wind direction, whereas in case of this it is exactly the opposite. So depending on the vegetation characteristics and the wind supply, I beg your pardon, sun supply and the wind direction and the speed, different types of dunes are formed, and different deserts have got different dunes. Some of the very interesting photographs in Namib Desert, they are national parks. Wherever they are accessible, the governments exploit these areas for public, especially for tourism. So ripples, very, very attractive to look at Namib Desert in Namibia. The size, shape and orientation of the dunes are determined by available sand, vegetation and the wind, which I have already said before. There are different types of dunes. Longitudinal dunes, sometimes they can be as long as 160 kilometers. They are there in Sahara, up to 300 and a meter in height, that means quite a lot of height, and they run for kilometers, and we find them in Thar Desert as well. Barkhans, they are ice light slip phase are on the concave side. In the Thar Desert, they are formed along the margin of the rocky desert of Jaisalmer, Pokhran, where 2 to 3 meter high we have got it there in Thar Desert. Transverse dune, the long dunes which are against the direction of the wind. Parabolic dune, they are crescent shaped but very long, exactly opposite to a Barkhan. The horn is towards the wind direction. There are many such pictures available. Star dunes, where sand is less available. Dome dune, a dune which does not have any shape. So based on different shape, different deserts have given different names. Then reversing dune, dunes which are half cut, there are several names. Dras, Dune 9 in Savleski, Namibia, which is 300 meters of height. These are the nevkas where the vegetation has been formed. And dune field, one dune after the other. So sand dune is one of the most well known and important depositional feature. And the last is the loess. Loess is in several large mid-latitude areas of the world, the surface is covered by deposits of wind transported silt, which has settled out from dust over thousands of kilometers. I'll give you an example. This is loess. Loess is, sometimes it is 50 meters, 100 meters of height. They are very fine silt or clay material which is blown away from a desert, carried for outside that desert and deposited elsewhere. China has got plenty of this kind of loess deposit. And what is the source? From our own Thar Desert it is going there, because silt and clay, they have got very low settling velocity. So they are carried for a very long time, for a very long distance. And in due course of time, they are settled on top of other and compacted and form even plateaus. They use it for agriculture at many places, and we can even see they are so compact that even caves are formed into it. But another word of caution, most of the loess, when we talk about, they are not found in the desert itself, except for very few. They are found outside the deserts. So I believe I have said, in a nutshell, I have given to you what is the aeolian feature. Only one word to end. When I say desert topography, we should not confuse and believe that desert means only wind. No. In desert, rain falls sometimes, and that does enormous erosion, and they also create landscape. And therefore, when we talk about desert landscape, we talk differently. That work of wind and a work of water separately. What we have done today is the work of wind, because there are deserts in the world where different types of features are formed because of water, which was not a part of this. But we have covered everything that we need to understand about the work of wind in the desert. So let us summarize what we did today. We started with the definition of desert. Deserts are areas where rainfall is less than 20 centimeter or 25 centimeter annually, even less than that. Deserts are the areas where water is deficient, and therefore the main geomorphic agent is mechanical weathering and the wind. And we did how the wind erodes, how it transports, what are the different features that wind forms, both erosional as well as depositional. We also have seen that some of the depositional features which are formed in one desert can go and get deposited elsewhere, and wind erosion compared to the other geomorphic features like river erosion is less effective, because in case of river we know that it can carry big boulders or during the flood, or it carries lot of sediment, whereas wind can carry only very fine sediment, and therefore by and large wind is not that dramatic agent of erosion, but nonetheless deserts are shaped by this aeolian process. So we have just seen the aeolian process and landscape. The next lecture will be weathering. Weathering means a fresh rock when it is exposed to atmosphere. Without any agent, the atmosphere itself is going to break it and soften it in situ. Weathering precedes erosion. First, the rock has to be softened for all the agents of erosion to be able to erode and form landscape. So erosion is actually the second step before weathering. That means we will be studying in the next lecture the basic, or once we come out of the interior of the earth, the first thing that we face is atmosphere, and how atmosphere reacts with the rock and what it does. That is called as weathering.